Problem number 5 says that Howie has designed these cylindrical drums. Complete the table. So I did complete the table. We found the ratio of all of these pieces, and the fact that we got 3/2 on all of them tells me that these are not similar, because this is a centimeter unit. This is a centimeter unit. So those two should be the same, but this one being a square centimeter, in other words, centimeters squared, if they were similar, then this would have been 9/4, not 3/2. And you can see right here that you write these two as a ratio, it reduces down to 3/2. So that's how we know that these two cylinders are not similar, because we didn't get the proper ratio for this the area, and we didn't get the correct ratio for the volume. So this is centimeters cubed. It says right there that it's cubic centimeters. So that means this one, if it were similar, would be 27/8, because 3/2 cubed would be 3 times 3 times 3, and 2 times 2 times 2. So that is justify whether or not the two cylinders are similar. We would say not similar because of these two ratios. Okay, so this is the part that you have to have memorized. So they're using this A over B as the scale factor. Don't forget, it can also be written like this, A to B. The scale factor, if they're comparing a dimension or a perimeter, because remember, perimeter, if I'm measuring in inches, my perimeter is going to be in inches. If we're measuring an area and the dimensions are in inches, my area is going to be inches squared. And I don't have to be using inches. I'm sorry, I could be using units. So let me redo this. So this will be units, this would be units squared, and this would be units cubed, because it is volumes. Area is units squared, volumes is units cubed, perimeters and dimensions are just units. So if this is the scale factor, then the scale factor, the ratio for my perimeters is going to be the same as my scale factor. They're going to be equal. The areas is going to be squared, and that means both of them are squared. So if you wanted to write it A squared over B squared, or A squared to B squared, this would be A to B. And then, of course, for cubed, it's going to be A over B cubed. You could go ahead and write it A cubed over B cubed, and then write A cubed to B cubed. Write a conjecture about the ratio corresponding to perimeters in any solid. It's A to B. Of areas, it's A squared to B squared. And yes, you could be writing A over B. A squared over B squared. Write a conjecture about the ratio of volumes. A cubed to B cubed equals A cubed to B cubed. That's the part that has to be memorized, and that will be like your so-called formula for when you're working the problems that you're going to be working. Okay, on number 8, they give us a tetrahedron. I don't know if you are aware, but a tetrahedron is like a triangular shape. All of the edges are 6 on this one. So this is 6, this piece is 6, this piece is 6, this piece is 6, that dotted piece is 6, and this one over here, they're all 8. That's a tetrahedron is this shape where all faces are triangles and they're all the same measurement. So we know then that our scale factor is 6 to 8. But it's not going to be written as 6 to 8. Why? Because that will reduce, divide out the 2's, and it'll be 3 to 4. So that's the scale factor of all of the dimensions and any perimeter. But they're asking here for the ratio of surface area. So area is units squared. So we're going to take 3/4 and square it, and we get 9/16. That's going to be the ratio of the areas. What is the ratio of the volumes? We're going to take the ratio of the dimensions, the scale factor, and cube it. So that's 27 over, oh gosh, is that 64? 4 times 4 times 4. Yeah, 64. So the ratio of the volumes. On problem number 9, they give us the ratio of the volumes. So pretend like we knew it was 27 over 64 and work backwards. How do you work backwards? How do you uncube something? You take the cube root of it. So we're going to write the volumes at 125 pi over 64 pi. And goodness, that does not look like a 64. And I'm going to take the cube root of 125, and I believe that's 5. The pi's divide out. The cube root of 64, we just saw that that was 4. So the scale factor for those two cones is 5/4. And the ratio of the perimeters is going to be 5/4. What would the area, the ratio of the areas be? 25/16. And we need that information down here. The total area of the larger cone is 75. So I've been putting since the larger cone is given, I've been putting that on the top, and the smaller cone goes on bottom. That's what I'm trying to find. And I know that if this is the scale factor, that's the scale factor, then the ratio of the areas is going to be, ratio of areas is going to be 25/16. So this 75 pi over what will reduce to 25/16. Now it's just a proportion, and that's easy peasy. What do we do? Cross multiply. Multiply the 75 pi times the 16, and then divide by the 25. So cross multiply, we get 16 times 75 pi, and that's equal to 25x. Divide both sides by 25. And my writing is really, really sloppy. 16 times 75 pi divided by 25. I'm going to be using a calculator. I'm gonna leave the pi out of my calculations because I'm gonna have pi as my answer. So 16 times 75, I'm gonna press enter, and then I'm gonna divide that by 25. And that gives me 48. So my smaller cone has an area of 48 pi. Okay. That should be, to the exercises. So we're going to go ahead and assign you, let's go ahead and assign you number 12, 13, and 14. And I'm going to look at the end of the unit practice, and I'm probably going to assign you some more. So I'll be right back. Okay, so for this lesson practice, do 12, 13, and 14, and then on the following 2 pages, do numbers 6 through 13. That will be your assignment for lesson 37-2.